friends, again we are continuing. We have some questions at around from 32 to something 39. I think some questions are left. So from the NCERT CBSE standard 12 exercise 7.2, and here I am going to solve a question number 30, 31, 32. So this question is little tricky, so just pay little attention. And then you have I equals integration 1 over 1 plus cot x dx. So what we do that we replace this cot x by cos x by sin x. So this becomes 1 over 1 plus cos x upon sin x dx. So on simplification this will become 1 over sin x plus cos x upon sin x dx. On further simplification this will become sin x upon sin x plus cos x dx. Now we have to find, because if you take sin x plus cos x as t, on differentiation you will get the cos x minus sin x, and if you take something else then again you never find the sin x dx. So we have to do little manipulation here. So if you see what is the differentiation of this, I write it as cos x minus sin x differentiation is cos x, this is cos, and this is cos x differentiation is minus sin x. And then what is the number itself or the denominator itself? So this is sin x plus cos x. So if you add these two, then you see that if you add these two, then you get sin and sin gets cancelled and you will be left with 2 cos x. But if you subtract, then sin x and sin x will add up and cos x and cos x will cancel each other, and this you'll get as 2 sin x. So at the place of this sin x we are going to write half of this whole thing. So the half outside, and this becomes sin x plus cos x minus cos x minus sin x whole divided by sin x plus cos x dx. Now this is the standard form. Then what we need, that we need to break this down into 2 or more terms. So here I can write, so I think if I remove this part it will be much more better. So from this part I am going back to this part. So let me write here I, and then this question is little tricky. So I we can write as half integration of sin x plus cos x, sin x plus cos x over sin x plus cos x dx minus half integration of cos x minus sin x, can be written as it is, just write cos x minus sin x over sin x plus cos x dx. Now this part, the first one, this one cancel this one, so you have just 1 dx minus 1 by 2 integration of this one. So if you see, if you take sin x plus cos x as t, you will get dt. Here in the last, just before clearing the screen, we have discussed this part. So this you can say this is dt and this is t. So if you take the integration, because if you take sin x plus cos x, for sake of convenience I am writing here this sin x plus cos x as t. So this cos x minus sin x dx is just dt. So this becomes dt, and then on integration you have 1 by 2 x minus, this is half log mod, so half x minus half log t plus c, and then at the place of t you write this whole term. So this is half x minus half log mod sin x plus cos x plus c, and this is I. So this is done like this. Okay, so the very next question is just similar to the very same question. Instead of this, we have just 1 minus tan x. So now the next question, that is question number 33, 30, 31, 32, 33. Yes. So this is question number 33, and this goes like 1 over 1 minus tan x. These two questions, 32 and 33, these two questions are a little tricky. That's why I'm just going slow. So first what you can do here, that you can write this as, at the place of this you write sin x by cos x. So 1 over 1 minus sin x upon cos x dx. This can be written as 1 over cos x minus sin x upon cos x dx, and this will become integration of cos x over cos x minus sin x dx. Now we have to, again just like the previous question, we have to dissolve, or you can say we have to express this numerator in terms of the denominator or the differentiation of denominator. So what differentiation of this term you'll get? You'll get the minus sin x and the minus cos x. This is just kind of sin x plus cos x. So I write here sin x plus cos x. This is the normal differentiation of this, and the term itself is cos x minus sin x. Cos x minus sin x. Now we need cos x in the numerator, so I simply just add them. So you see, sin x and sin x cancel, and cos x add up, and then you get 2 cos x. So 2 cos x is just this denominator, which is cos x minus sin x, and the plus the differentiation of this denominator, that is sin x plus cos x. But actually the differentiation of this denominator is giving you minus sin x minus cos x, since I have taken minus common, or I can manage that while solving the integration, so I don't consider it right now. So I now have this cos x as this, so only cos x will be half times this. So I write half here outside, and this becomes sin x plus cos x plus cos x minus sin x, everything divided by cos x minus sin x dx, and this breaks down as 2 integral. One is this upon this. Okay, so that is sin x plus cos x over cos x minus sin x over cos x minus sin x dx, and the plus second integration is also half times this upon this cos x minus sin x over cos x minus sin x. So I can just write it as 1 because they two cancel each other. Now in this form, if you just take let cos x minus sin x as t, you get minus sin x minus cos x dx as dt. So if you take minus common, it is sin x plus cos x dx as dt. So this minus, this becomes minus 1 by 2 dt over t plus 1 by 2 integration of 1 dx. So this becomes minus 1 by 2 log mod t plus half x plus c. Now replace the value of t, and this is the final answer. So 1 by 2 log mod cos x minus sin x, cos x minus sin x plus half x plus c. So this is your final answer. Now we'll go for question number 34. Now question number 34. I is integration of root tan x over sin x cos x. Sin x cos x. Now how to solve this particular question? So I think there is one method which is going to help. Like if I divide both numerator and denominator of this particular question, then we can get a better term. How? Because if you divide the expression by cos square x, so dividing numerator and denominator by cos square x, what do you get? So here you get 1 over cos square x under root tan x. Over there you get sin x over cos x divided by cos square x. Now this 1 cos cancel this power and this becomes tan, and this 1 over cos square x becomes sec square x. So this becomes sec square x under root tan x, and this becomes tan x, and this is your dx. Now this is the standard form. So now if I reduce this by this, so I get sec square x over under root tan x dx. So let tan x equals t. So on differentiation you get sec square x dx as dt. So this question becomes dt upon under root t. So I can write this as t to the power minus half dt, and this on integration gives you 2 root t plus c, and the root t now you can write as 2 root tan x plus c. This is all about this question. Now 35. So this is the time that we could move a little faster. So here I go. I is under root 1 plus log x whole square over x dx. Let 1 plus log x as t, 1 over x dx as dt. So this is t square dt. This is t cube over 3 plus c, that is 1 plus log x whole square, whole cube by 3 plus c. Done. Now we go for number 36. Number 36 question goes like integration of x plus 1 x plus log x plus log x whole square over x dx. Now see, interesting part is x plus log x. Let that as t. So x plus log x as t, 1 plus 1 over x dx as dt. So this is x plus 1 over x dx as dt. X plus 1 over x, you can see directly is there. So I now becomes just t square dt, that is 1 by 3 t cube plus c. At the place of t you write the answer, this value, not answer, is x plus log x. So x plus log x whole cube plus c. This is question number 33. Now question number 37. Integral I is x cube sin x tan inverse x to the power 4 over 1 plus x to the power 8. How we can solve this question? Now this is dx. So first we write let tan inverse x to the power 4 as t, 1 over 1 plus x4 square into 4x cube. Differentiation of this. Tan inverse something. Tan inverse x differentiation is 1 over 1 plus x square, and tan inverse something differentiation is 1 over 1 plus something square. So 1 over 1 plus something square into differentiation of this x to the power 4. This is 4x cube dx, and this you get as dt. So you see we have found 4x cube over 1 plus x to the power 8 dx as dt. So x cube over 1 plus x to the power 8 dx is dt. So this 4 should go here, dt over 4. Now my question becomes this: sine. I don't think there should be sine. I think this is not there. Maybe I have copied it wrong. I'm pretty sure. So I'll go by this. So my question becomes, this is, yes, so 1 by 4 dt by 4, and this becomes just sine t. So this is 1 by 4 minus cos t plus c, and write the answer expression for this cos. What is t? That is tan inverse x to the power 4 plus c. This is the answer. This is done. Now question number 38. 10x to the power 9 plus 10 to the power x log 10 to the base e over x to the power 10 plus 10 to the power x dx. Now those who remember the formula, they know that x to the power 10 is 10x to the power 9, and x to the power 10's differentiation is 10 to the power x log 10. So if this is t, this whole thing is dt. But let me explain you. This is x to the power 10 plus 10 to the power x is t. So 10x to the power 9 plus 10 to the power x log 10 to the base e whole thing dx as dt. So this becomes dt, and this is your t. So it is log mod t plus c, means just your answer is log mod x to the power 10 plus 10 to the power x plus c. Done. Now one more last question of this exercise. Question number 39. We have to find the integration of 1 over sine square x cos square x dx. Now you know that the 1 can be written as sine square x plus cos square x over sine square x cos square x dx. Now if you resolve this into two expressions, you have integration of sine square x over sine square x cos square x dx plus integration of cos square x over sine square x cos square x dx. So sine square cancel, cos square cancels, 1 over cos square x is sec square x dx plus integration, this is cosec square x dx, and the integration of sec square x is tan x, integration of cosec square x is minus cot x plus c. This is the end of this chapter. So this is 7.2 ended. Now in the next video we'll start doing with 7.3, and now I again expect you all to remember the formulas of algebraical identities, trigonometrical identities and trigonometry, along with the formulas of differentiation. Then your whole journey for integration will be quite easy and smooth. Thank you very much. Just subscribe to our channel and keep practicing with us.